Hi, welcome back. Again, this is Chem 104. This is part 5. This will be the last part of chapter 1. So temperature is just a measure of how hot or cold an object is. So it's what we use so that we can say this is hotter or colder than something else. So there are 3 temperature scales. Celsius, which is used pretty much globally, the Kelvin scale, which is used in science and engineering, and then the Fahrenheit scale. The Fahrenheit scale is what we call the English system, and that is used in the United States, and just about that's the only place. And so what that does is, since we read temperature in Fahrenheit in the U.S., then we have to convert it usually. And so your conversions are listed here for you. If you know the degrees C, you can calculate the degrees Fahrenheit by saying 1.8 times degrees C. You do this first, and then you add 32. Alright, so that'll give you Fahrenheit if you're given Celsius. Usually, though, what we're doing is we're converting Fahrenheit to Celsius because that's generally what we use. And so your degrees Celsius is going to be degrees in Fahrenheit minus 32. You do that first, and then you divide by 1.8. It's very important that you do them in the right order. So one thing that's nice is if you're in Celsius or you've converted to Celsius, if you need to convert it to Kelvin, then you just add 273 to Celsius, and that will give you Kelvin. If you have Kelvin and need to go back to Celsius, then you just subtract 273 from whatever your Kelvin is. The only time that this is tricky is if you have negative signs, so you need to really make sure that you have those negative signs and follow the rules of that. So this is just a comparison. Celsius is nice. It's a metric type system, so water freezes at 0 and it boils at 100 degrees. In Kelvin, since we just add 273, the increments of the scale are exactly the same because there's just 100 Kelvin between 273 and 373. In the English or Fahrenheit scale, there's 180 degrees difference between the 32, which is the freezing point of water, and the boiling point, which is 212. So it's just a little more difficult to do calculations with it. This absolute zero down here is 0 Kelvin. We call it an absolute scale, okay, because absolute zero is basically where there's no molecular movement. All right. And so in Celsius, that would be a negative 273 Celsius, very cold, or a negative 460 degrees Fahrenheit. So absolute zero is super cold. All right, so just you need to be able to convert these for problems, and so I'm just going to give you a couple, and I'm going to give you some with a negative sign so you can kind of get that. All right, so methane, which is CH4, boils at a negative 162 degrees Celsius. What is the boiling point in Fahrenheit and in Kelvin? Okay, well, Kelvin's the easy one, right? Because Kelvin is going to be the degrees C, what? Plus 273. So that's going to equal a negative 162 plus 273. And when we do that calculation, that will give us 111 Kelvin. Okay, because this was a negative. To do the other calculation, we're going to say Fahrenheit, degrees Fahrenheit. Notice Kelvin doesn't have degrees. Degrees Fahrenheit equals what? You remember? It's going to be degrees Celsius times 1.8 plus 32. All right, and I said it's very important that you do this part first. So negative 162 times 1.8, I'm going to do that first, and then I'm going to add 32 to that. And that answer is a negative 260 degrees C, and that's using the correct number of significant figures, which would be 3, right? Don't forget the significant figures. Okay, if it's 70 F in Alabama, what is the temperature in degrees C? So we know degrees C equals degrees F minus 32 divided by 1.8. Okay, so this might be something, if you have a hard time remembering these formulas, this might be something that you write on your 3x5 index card. Okay, all right, so our degree C is equal to, isn't that what we're doing? Yes. Okay, degree C is degrees Fahrenheit, which we just figured out it was what? 70 degrees, because they gave it to us. So 70 degrees Fahrenheit minus 32 divided by 1.8. Super important, if you're putting it in your calculator, that you do 70 minus 32 and then hit enter. Or you can put it in parentheses if you're good at your calculator. If you're not really good with your calculator, then don't take any chances, because when you do this correctly, the answer you're going to get using the proper significant figures is going to be 21 degrees C. If you put that in your calculator and you do not get that, because this is the time to practice with your calculator, it is not the time to practice with it when you're doing your test. Okay, so make sure that you can get these same numbers that I'm getting when you put it in your calculator, so you'll know you're doing it correctly. Alright, so that was temperature. So temperature, we're just doing conversions, because a lot of times it'll tell you the temperature in C and you're going to have to convert it to Kelvin or something else like that. Density. Density is what we call a derived unit. A derived unit. So density is a physical property, that is, it doesn't change chemically. And so when you look at density, you're going to be seeing what mass a certain volume takes up. So density is equal to the mass of whatever that substance is divided by its volume. And we typically do grams over milliliters. Now I have cc's here, and when I say cc, I'm talking about cubic centimeters. And that makes sense for us when we're talking about solids. Okay, if we can have solids and solids, like you know, those amalgams, those silver looking fillings that the dentist puts in sometimes, that's an amalgam, and that's technically a metal in a solid in a solid. Okay, he liquefies them first so that he can mix them together, but they're a solid in a solid. So you can use cubic centimeters in that case. Most of the time we're going to be using grams per milliliter for our liquids, and then you might see grams per liter when we're talking about gases, because they take up a lot more volume. Alright, but density is mass over volume, and so if you're going to convert milliliters to grams, you have the perfect conversion factor, because you can cancel your milliliters and get grams. So it's a bridge, if you want to think about it that way, going from the world of volume to the world of mass, or from the world of mass to the world of volume. Because remember, with a conversion factor, we can write it either way. We can write grams over milliliters or milliliters over grams. Just remember, the number is going to go with the grams. So as an example, if the density of acetic acid is 1.05 grams per milliliter, what is the volume of 5 grams of acetic acid? Now, since it's grams per milliliter, the other way of writing that is what? 1.05 grams, like a fraction, right? Don't forget, because that's the way things are going to cancel out when we're doing the calculation. And we're given 5.0 grams of acetic acid. Don't worry about what the how you write that or anything. I'll just write AC for it, okay? Alright, so what can we measure or hold in our hand? The grams of acetic acid. Why? because 1.05 grams per milliliter is what? A property. It's a conversion factor. So we don't start with the conversion factor. So we're going to start with our 5 grams of acetic acid, and then we're going to say the solution, okay, is 1. Now, let's think about how we did our conversion factors. All right, so we've got grams here, and I know that I don't want grams, I want milliliters when I get done. So what am I going to put on the bottom immediately? You got it, grams, okay? So 1.05 grams, and then the 1 milliliter is going to go on top, okay? Because this is the same thing as it's 1 milliliter if you don't put a number, okay? So you can write it either way. So I'm writing it this way because I want to what? Cancel those grams of acetic acid, and then I'm left with milliliters as my unit. And so 5 grams divided by, where am I? 5 grams divided by 1.05 is going to be 4.761904762 milliliters. And that's what I'm going to answer, right? No, that is not what I'm going to answer. What am I going to answer? I'm going to give that how many significant figures. Conversion factor has unlimited, so I don't worry about that. The measurement is the one I go by. It has how many? 2. So my answer is going to have what? 2. So my answer is 4.8 milliliters. Specific gravity. I'm mentioning this because sometimes you'll see specific gravity. Nurses see specific gravity in urine, okay, and it's kind of a measure of how much stuff you've got in your urine, okay. The more salts and proteins and things like that that you have dissolved in your urine, the higher the specific gravity will be. All it is you're comparing the density of the substance that you're looking at, like urine, with the density of the water, as long as they're at the same temperature. And so notice that since specific gravity is the density of the substance divided by the density of the water, it has no units because what? Those units cancel. All right, a lot of people use specific gravity and density interchangeably. They're technically not the exact same thing, but a lot of times you'll see that, so don't let that bother you. All right, calculate the density of a substance if 742 grams of it occupies 97.3 cubic centimeters. Remember that our cubic centimeters, we can always also write that as cc's or milliliters. They're all equal. Okay, so it's the same exact thing. So if we're calculating the density using cubic centimeters, we're going to have density equals 742 grams over 97.3 cubic centimeters. How do I know that? Because it's going to be what? Mass over volume. And I know grams are mass, and I know cubic centimeters or milliliters or whatever is going to be volume. So I just have to plug that in. So 742 grams divided by 97.3 is going to give me 7.63 grams per cubic centimeter. And I used 3 significant figures in my answer because I had 3 significant figures in the problem of the thing that I could measure. And really I could measure both of those, couldn't I? So technically I would have to look and see which of those was less. Make sense? All right, second practice. Suppose you need 125 grams of a corrosive liquid for a reaction. What volume do you need if you know the liquid's density is 1.32 grams per milliliter? So this time you're given grams, and it wants to know milliliters. And again, density is what? The bridge between grams and milliliter, or mass and volume. So what I measure is 125 grams. So 125 grams times, grams has got to go on the bottom, right? So I've got this thing right here, which really means 1.32 grams over 1 milliliter. So I've got 1.32 grams and 1 milliliter because I can write them either that way or 1 milliliter over 1.32 grams. They are equal. And so when I do that, my grams are going to cancel, and I'm going to have 94.7 milliliters because I have 3 significant figures there and 3 significant figures in my answer. Piece of cake, right? All right. The last thing we're going to do is, this is something that we see in the lab a lot, and we do density by displacement. Okay, density by displacement. So basically what we do is we have a graduated cylinder or something, and it has a certain level of liquid in it. If I put something in it, like this key, then that's going to displace the volume of some of that water, and it's going to cause this to rise a certain amount. Like, I think about getting in the bathtub. If you have the water all the way to the top of the bathtub and you get your body in the bathtub, what will happen? It will overflow, won't it? Because the volume that you take up is now taking the place of some of that water, and so that water has to go somewhere. So that's why you don't fill it up all the way to the top before you get inside. So we can use the difference in the volume to figure out how much volume the solid displaces. This is really good for things that you can't calculate what their volume is. They're not like a geometric shape or anything. They're not a cube or whatever. And so what we do is we say density is equal to mass over volume, or grams over milliliters. Okay, now I have a couple of things here that I can take inventory of. I have 31.0 grams, so I know that's going to go on the top here. And then I've got two numbers. I've got, you had 5 milliliters of water, and then the water level rose to 9.32. So what that tells me is the change in the volume is how much volume my key took up. So I have to get 9.32 milliliters minus 5 milliliters, which I think is 4.32. Yeah, 4.32. I'm terrible in my head. I don't know about y'all. 4.32 milliliters. That's the difference. That's how much it rose. So that's how much volume that displaced. So you just take the difference in those two numbers. And so the density is going to be equal to grams over milliliters. So in this one you just have to subtract those numbers to get your volume. And so it's 31.0 grams divided by 4.32 milliliters. And that's going to give us 7.18 grams per milliliter. Okay, so when it's displacement just means it takes the place of, and so we just do that a lot in the lab, and so that's why it's important that you can do an example that's like this. Okay, you'll also see this, I think, in the lab, on the online virtual lab. Alright, so this is it for Chapter 5. Thanks for staying with me. I hope we learned something. If you have questions, as always, give me a shout. Practice, practice, practice. You have online homework to do, so make sure you get that done.